Okay, part 2 of 3 for the chain rule is actually going to get into the chain rule. We sort of did that with the general power rule, but this will go into our other functions. So the chain rule basically states that you take the derivative of what's outside times the derivative of what's inside. So if we look at this, where we have two functions, our composite function. So it's better to just go by example. This first example follows our general power rule, which is also our chain rule. Bring the power in front, raise it to the n minus 1, and then take the derivative of what's inside, and then clean it up. 3/2 of 6 is 9. Okay, let's look at the next one. We have e to the x. So if we think of this as e to the u and 2x to the third plus 5, the derivative of e to the u is e to the u, and the derivative of 2x to the third plus 5 is 6x squared. So the derivative would be e to the u, which is 2x to the third plus 5, times our derivative of that exponent, which is 6x squared. Looking at the next one, we have the natural log of a function, and then our function. The natural log is 1 over u, derivative, and then the derivative of this would be 2x minus 4. So when we take the derivative of a natural log, it's 1 over u, which is x squared minus 4x plus 2, times our derivative of the function inside, which we just write Okay, there are 3 for you to try. Oops. So, general derivative rules are summarized there, where we just showed all of those. There's our general power rule, our derivative of natural log. It's 1 over the function times the derivative of the function, and derivative of our exponentials. And let's go ahead and do a few more examples. Derivative of e to the 2x. Take the derivative of 2x is 2, And then e to the 2x is just e to the 2x. Natural log is 1 over the function with the derivative of that function in the numerator. All right? You have matched problem number 5. Think of this as more than one function. So I'm going to kind of get you started here. Think of this as, we'll say u to the third. And then we have the natural log of v. And then you have our 1 plus e to the x. So that when you take your derivative, it's 3u squared, 1 over v, e to the x. So it would be all of these multiplied together. Now just substitute in what I let everything stand for. And let's do this example here. We have first u to the third, and we have 1 plus e to the v, and we have x squared. So this is 3u squared, this is e to the v, and this is 2x. So 3 times 1 plus e to the x squared squared times e to the x squared times 2x. So we get 6x e to the x squared times 1 plus e to the x squared squared. Those are a little bit more challenging. And you have the last 3 problems to try. Okay, hopefully you were successful in all those. I did not write my answer up here to confirm your match problem 5, so let me just do that real quick for you. And there should be an e to the x up here. Okay, and this concludes part 2